Hello and welcome class. So in today's class we are going to start a new chapter named Force and Laws of Motion of class 9th NCERT chapter number 8. Okay. So in this chapter we are going to introduce you with a new term named as force. What is force? We are going to learn about unbalanced force, balanced force. Okay. Then we are going to learn about three laws of motion given by Newton. Also, we are going to learn about some new terms like momentum. Okay, so let's begin this chapter, force and laws of motion. In previous chapter, we described the motion of an object along a straight line in terms of their position, velocity, and acceleration. So, in the previous chapter, motion, we have mainly studied the motion of any object along straight line. That any object is moving in a straight line, then what will be its distance, what will be the displacement, its speed, its velocity, and its acceleration. And we also learned about three equations of motion. We saw that such a motion along a straight line can be uniform. Uniform motion means at constant speed. Non-uniform motion, it means the speed is varying continuously. We have not yet discovered the what is the cause of motion. In the previous chapter, we just talked about motion. We haven't discussed what is actually causing any object to move from one place to another place. Why does the speed is changing with time? How can our body accelerate? We haven't discussed these cause of motion. We just learned about what are the phenomena around the motion. So, does motion require a cause? Okay, this object is in rest. Okay, it will continue stay here in the rest position. Okay, if I want this object to do motion, I have to provide it a force. Okay, so that this object will do motion. So yes, motion requires a cause. Motion requires something which causes that object to move from its position. If so, if yes, what is the nature of this cause? In this chapter, we are going to learn about this cause. Okay, we shall make an attempt to quench all such curiosity. Clear, class? For many centuries, the problem of motion and its cause had puzzled scientists and philosophers. Okay, okay, a ball is on ground. A ball is on ground. We give a small hit, it does not move forever. Okay, we give it a small hit, it moves at few distance. Okay, but it will eventually stop after few time. Such observations suggest that rest is the natural state. Any object which we will give force, it will move till some distance, then it will reaches the rest position. So lots of observations suggested that the rest is the natural state of any object. So it was believed that the natural state of any object is rest until Galileo Galilei come in picture and Isaac Newton, which develop a different approach to understand the motion. And what is that different approach? Okay, this is a trolley. Okay, the trolley moves along the direction in the direction we push it. Clear, class? This boy is pushing the trolley in this direction, so the object is moving in this direction. Okay, this girl is hitting the ball with hockey stick in this direction, and this ball is moving in the same direction, forward direction. So the pushing, pulling, or hitting the object changes the state of the motion. In all these examples, this ball or this cart, trolley, both the object was initially at rest position, but when you pull, push, or hit, or do anything, the state of object changes and it returns back to its motion. In our everyday life, we observe that some efforts is required to put a stationary object into motion or to stop a moving object. For example, you are playing a football. The football is in stationary position. When you hit or kick the football, it returns back to its motion position. Okay. Now the new state of the football is motion, and when the goalkeeper, catches the ball, then the ball reaches back to its rest position. So you have to make some efforts to make any stationary object into motion and to make any motion object into stationary position. We ordinarily experience this as muscular effort. Generally, to do this, to make any motion object in a rest position or to make any rest object into their motion position, we have to apply some muscular effort. It means either you have to push it, you have to pull it, hit it, or catch it to change the state of the motion. And the concept of this push hit pull is known as force, that you are applying some force to an object. If I want this pen to come in motion position, I am applying a force, I am pushing this object, and this push is known as force. So to change the state of the motion of any object, you need force. What is it? In fact, no one has seen, taste, or felt a force. Force is just a effect. Okay. However, we always see or feel the effect of force. It can be only explained by describing what happened when a force is applied on an object. Okay. You cannot see, taste, or feel the force. It is just a effect, and you will going to see the force when something is happening to an object. Pushing, hitting, pulling of an object are all the way to bring object in motion. They move because we make force act on them. If there is a cricket ball, someone throws the cricket ball and you hit the cricket ball is doing motion. Okay. And how it is doing motion? Because you have hit the cricket ball. It means you have applied a force on the cricket ball. So anything which is moving, we make it move by applying force. Okay. If any object is coming back to stop position, for example, somebody hit a ball, okay, and you catched it. So first that ball was in motion position and you have catched it. So it means now that ball has returned back to rest state. And to make that ball come back in rest state, you have applied force from your hand. Okay. To it means that if you want any object to do motion, you need to apply force. If you want any object which is in motion, you want to stop the motion, you want to make that object in rest position, you have to apply force. From your studies in earlier class, you have also familiar with the fact that force can be used to change the magnitude of velocity of an object. If an object is moving slowly, you just apply a force and that object will start moving in fastest. So you can use force to change the magnitude of velocity. Forces are also applied to change the direction of the motion. For example, a river is streaming in this direction. You have put a barrier here. Okay. So what will happen? This barrier will push the object to change its direction. So what this barrier is doing? Barrier is applying force to change the direction. So force can change the speed, okay, and also can change the direction of motion. We also know that force can change the shape, the size of the object. Okay, there is a tin can, you apply force from your hand, it will deform. How? Because force can change the shape, also the size of the object. Okay, this is a spring, this is the natural state of the spring. If you are applying force in both the direction, the spring elongated, it means the force is changing the shape of this spring. Okay, this is a rubber ball. Okay, you are applying force, so this spherical shape will become a elliptical shape. It means force is used to change the shape of this rubber ball. Now let's talk about balance and unbalanced force. Okay, I'm going to show you one diagram. Okay, this is a table, a block is placed here. Okay, and let's suppose two students, these two are stringed attached and two students are trying to pull it. Okay, let X is a strong person and Y is a weaker person, so it will pull this block with much higher force, so this block will start moving this word, this in this direction. Okay, either the Y is pulling it in opposite direction, still the block will move in this direction. Okay, class? So there is a horizontal table and you have put a block in it. Okay, two strings are tied with this block. One is X, one is Y, in two opposite faces. Okay, and if we apply a force by pulling the string X, the box will begin to move in rightward direction. This is the block. This is the string X and this is the string Y. Okay, if you apply a force in string X and start pulling the string, okay, then the block will start moving in X direction. In similar way, if you leave this string and start pulling string number Y, then the block will start moving in Y direction. But if the block is pulled with both the direction, okay, this is the block, this is the string. Now you both two person are pulling this string in both the direction, in this direction also, in this direction also, with same force. The magnitude of force is same. What will happen? The block will not move anywhere. Okay, so if two forces are applied in equal and opposite direction in such a manner that object does not move, force is there, okay, but the direction of force is equal and opposite such that the object is not moving, then such force is called as balanced force. Balanced force. And do not change the state, rest or motion of the object. Currently this object was at rest state. We have applied two equal and opposite force, okay, in such a manner that this object is not changing its state. Then such force is known as balanced force. Is it clear? Now let consider another situation that same block is, okay, and these are the two strings. Okay, let still this block is pulling, we are pulling this block in two opposite direction, but let assume that this force F is greater than this force F. Okay, so this F is greater than this F. So this object will go in this direction. Here the direction of force is opposite, but the magnitude of force is different. This capital F is much greater force in comparison to this small f. So this object is start moving in rightward. So there is not a balance between these two forces. So these type of forces are known as unbalanced force. The state of object is getting changed. The two forces are not balanced and the unbalanced force act in the direction of the block move. Okay. So unbalanced force always change the state of the motion and balanced force never change the state of the motion. Clear class? This was the example. So what happened when some children tried to push a box on a rough floor? There is a rough floor, okay, and this is a box. This is a box and some children are trying to pull it and it's a rough force. So children are applying force in this direction. But we know there is a force which always oppose the direction of motion, which is known as friction force. Friction force will act opposite in the direction of motion. So the friction force will try to stop the box, whereas children are trying to pull the object and the object is moving. It means that the force applied by children are greater than the friction force of the surface. Okay. So this is all about friction force. So in today's class, we have started a new chapter named Force and Laws of Motion, and we have learned what is force today. In next class, we will explore more about balance and unbalanced force and try to find the causes of motion. I hope today's class is clear to all of you. Thank you.